Lesson 22, uniform motion problems with equal distance and similar triangles and proportions. The first thing that we're going to be talking about is uniform motion problems. And in these problems, we've got two people who are going an equal distance, but they're traveling at different rates and different times. One of the things that we need to remember in dealing with these types of problems is this formula. Rate times time equals distance, right? Or RT equals D. Rate times time always equals distance. In these types of problems, it would be helpful to draw a diagram or sketch it out. All right, so diagram the problem, and that will help you in solving. We're going to do a couple examples before I have you do one on your own. All right, so let's go ahead and look at the first example. In the first example, Roger made a trip on Sunday. Judy made the same trip on Monday. All right, so you see already, first off, they're traveling equal distances. They're going the same trip. Roger traveled 12 miles per hour. Judy traveled at 20 miles per hour. So her time was 2 hours less than Roger's time. How far did they travel? All right, the first thing that we need to remember is rate times time equals distance. All right, we're going to keep that in our mind. We also want to diagram the problem out. All right, so we have Roger. Roger's going on a trip. And we have Judy. Judy's going on a trip. Now, their trip is the same distance. All right, so they have equal distances. Roger has a rate. Roger has a time. Judy has a rate. Judy has a time. All right, so now let's fill in some information. Roger made the trip on Sunday. Roger traveled at 12 miles per hour. Miles per hour is a rate. All right, you guys know rate as speed. All right, so his rate was 12 miles per hour. Judy traveled 20 miles per hour. So Judy's rate is 20 miles per hour. All right? Now, we're not given a specific time, but we do know that her, being Judy, all right, Judy's time was 2 hours less than Roger's time. So Judy's time was 2 hours less than Roger's time. We don't know what Roger's time was, but we can call his time X. And we know that Judy's was 2 hours less than that. All right? So Judy's time would be X minus 2. All right, so we have Judy's rate, and we have a definition of her time. We have Roger's rate and a definition of his time. Now, their distances were equal. Right? So we have the distance of Roger, which was equal to the distance of Judy. Now, we know that rate times time equals distance. All right, so rate times time is equal to rate times time. All right, and this is Roger, and this is Judy. So we're going to plug in Roger's rate in time and set it equal to Judy's rate in time. All right, Roger's rate was 12. His time was X. Judy's rate was 20. Her time is X minus 2. All right, so now we're going to solve for X. First, we're going to distribute. And then we're going to subtract. And we get X is equal to 5. Now, that is not the solution to the problem. That is just Roger's time. We need to make sure that we are solving for the actual question. How far did they travel? All right, well, if X is 5, that means Roger's time is 5. That means Judy's time is 5 minus 2, which is 3. All right, so we have their rate and their time. We're looking for how far, or what is their distance. This goes back to the equation, rate times time equals distance. So we take Roger's rate, which was 12, times his time, which was 5. His distance is 60. Now, they traveled the same distance, so their distances should equal. Judy's rate was 20. Her time is 3. 20 times 3 is also 60. All right, again, so we see distance equals distance. All right, and that is the final solution. They traveled 60 miles. All right, that is a uniform motion problem. All right, so keep in mind the equation R times D, T equals D, and then you want to sketch out the information. All right, let's take a look at a second example. Brer Rabbit. All right, Brer Rabbit hopped off towards the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began the chase from the same starting point. He caught Brer Rabbit at 2 p.m. How fast did he run? All right, so again, we're working with the equation, rate times time equals distance. let's sketch out our information. We have Brer Rabbit and we have Brer Wolf. Now, Brer Rabbit hopped off towards the briar patch at 10 kilometers per hour. Kilometers per hour is his rate, right? So his rate is 10. Now, he left at 10 a.m. That does not mean that his time is 10, okay? His time is the total time traveling. We'll come back to that in a moment. All right, and then we have Wolf. Brer Wolf. All right, now, he caught Brer Rabbit. So they ended up traveling the same distance. They started at the same point. They ended at the same point. But their rates and their times are going to be different. Now, we know that Brer Rabbit left at 10 a.m. and he was caught at 2. So his total time traveling is going to be the time from 10 to 2. So how much time was there from 10 to 2? That would have been 4. All right, so Brer Rabbit's time is 4. We have now his time and his rate. Now we need to know Brer Wolf's time and rate. Now we know Brer Wolf left at noon, and he caught Brer Rabbit at 2. So he only ran from noon to 2, which was 2 hours. All right. The question is, how fast did Brer Wolf run? So we're looking for his rate. We're going to call it x. Right now, they went equal distances. So the distance of Brer Rabbit was equal to the distance of Brer Wolf, which also means their rate times their time is going to be different, equal. So we fill in information. Rabbit's rate was 10. Rabbit's time was 4. Wolf's rate, we don't know, but we know his time was 2. All right, so now we're solving for his rate. 10 times 4 is 40. X times 2 is 2x, which means that x is equal to 20. All right, so Brer Wolf's rate was 20 kilometers per hour. And we have answered the question. That's all we need to solve for. All right, again, we're going to use the formula. Rate times time equals distance. And we sketched or diagrammed our information. All right, go ahead and try this next example on your own. If you need to, go ahead and pause the video, hit play when you're ready to move on. All right, the next thing that we are talking about is similar triangles and proportions. We've already talked about similar triangles and scale factors, but now we're going to solve for missing sides of a triangle using proportions. All right, a proportion is one ratio equal to another ratio, and a proportion is solved by cross multiplying and dividing. So all we're going to do is compare corresponding sides. All right, so the side across from the angle with 1 tick mark on the small triangle is 7. The angle across from the angle with the 1 tick mark on the big triangle is 9. So the ratio of those sides is 7 to 9. Let's look at the ratio of sides across from the angle with 2 tick marks. On the small triangle is 8, and on the big triangle is y. So the proportion is 8 to y. We have two ratios. If we set them equal to each other, we have a proportion, and all we need to do to solve a proportion is cross multiply and divide. We can do that and solve for y. All right, let's go ahead and take the last side. All right, we have side 5. It's proportional to side x. All right, so again, we have another unknown. We set it equal to the proportion of the sides that we do know, which comes back to 7 over 9. And we have another proportion where we can cross multiply and solve for the sides. The only thing that I want you to do to finish this one up is to go ahead and solve what is side x, what is side y, and then we'll check it when we come back to class.